Hello, this is Jonathan. Let me welcome you to yet another small session in which I'm going to illustrate how to simplify this given problem in matrix algebra. So the question goes like, an n by n invertible matrix A is said to be orthogonal if A times A transpose is equal to A transpose times A, which is equal to the identity matrix I. That is to say, A transpose is equal to A inverse. Part A, show that the matrix A is the matrix A given by this 1/3 by that is orthogonal. Part B, given that M is this matrix where omega and t are all real numbers, is orthogonal. Calculate M inverse times x if x is equal to that. Alright, so let me take you through the process of finding the solution of this problem. Now, first of all, we want to make use of the given definition. And the given definition is right here. So if we can calculate A times A transpose and reduce it to some I, and as well do the same for A transpose A and reduce it to I, then we would have proven that indeed the given matrix A satisfies this definition of orthogonality. So let's do that. Okay, so solution, part A, we want to calculate A transpose. This is none other than, so the ordered, let's just be consistent in the order. We want the matrix A first. So the matrix A is given as 1/3 into 1, 2, 2, minus 2, minus 1, 2. The last column is 2, minus 2, and a 1. Now we then multiply this to A transpose. Now remember, A transpose is this same matrix being altered its rows and columns. Now there's one thing to take note of. This 1/3 that is appearing outside, even for A transpose, it will be just hanging outside like that, and so it will appear like this. The 1/3 will be hanging outside for A transpose, but we interchange the rows of matrix A into columns of matrix A transpose. So the first row becomes our first column, which is 1, minus 2, 2. And the second row becomes our second column, which is 2, minus 1, minus 2. And lastly, the third row becomes our third column, which is 2, 2, 1. Okay, so let's try to do the multiplication here. So 1/3 times 1/3, we always get 1/9. And let's do this long multiplication. Let's try to expand things in this bracket. So we say row by column. This first row by the first column, we have 1 by 1, which is a 1. Minus 2 times minus 2, which is positive 4. This 2 here times this bottom 2, you end up with 4. And we evaluate the first row by the second column, you end up with 1 times 2, which is a 2, minus 2 times minus 1, which is a positive 2, and then this 2 times minus 2 is minus 4. Close that. I'm just putting brackets so that we clearly demarcate these numbers, because we should have 3 positions, right? 1, 2, 3. So if I neglect these brackets, then I may end up mixing up these numbers. That's why I'm just putting these small brackets. So let's do this other calculation. The first row times 30 column, we have 1 times 2, which is 2, minus 2 times positive 2, which is minus 4, and then 2 times 1, which is positive 2. All right. So let's do the same for the second row. We say second row in this first matrix times the first column, you end up with 2 plus 2 minus 4, close that, and then this second row times this middle column, we have 4 plus 1 plus 4, and lastly the second row times the last column, 2 times 2, we have 4, minus 1 times 2 is minus 2, and minus 2 times 1 is minus 2. We close that, and the last row will be 2 times 1, which is a 2, minus 4 plus 2, and lastly we say this last row by the middle column, we have 4, 2 times minus 1 is minus 2, minus 2, and lastly we have 2 by 2, which is 4 plus 4 plus 1. Okay, so let's simplify stuff. You end up with 1 over 9 out into this first part gives us a 9. I can neglect the small brackets now. 0, 0, 0, 9, 0. You simplify those brackets, you end up with that. Now if I effect the 1 over 9 into this bracket, I'll end up with this well-known matrix. 0, okay, that should be a 1, 0, and then 0, 0, 1. Now this is none other than the identity matrix I. So we have calculated one end of this definition to say A transpose should give us I. So let's calculate A transpose times A and see if we can recover I. So let's do that. A transpose times A is none other than A transpose will always have this 1/3 out, and then the A transpose, you remember, rows into columns and columns into rows, so you end up with A transpose being 1 minus 2, 2, 2, minus 1, minus 2, 2, 2, 1, and then again we multiply with matrix A, which is given to be 1, 2, 2, minus 2, minus 1, 2, 2, minus 2, 1. Okay, so let's do the multiplication. 1/3 times 1/3 is 1 over 9, and if we do the multiplication inside here, we have 1 times 1 is 1, 2 by 2 it's 4, 2 by 2 again, that's 4. Then the first row by the second column, we have minus 2, 2 times minus 1 is minus 2 again, 2 times 2 is positive 4, and then the first row, last column, we have 1 times 2, we have 2, 2 times minus 2 is minus 4, then plus 2. We close our matrix, and then we say the second row by the first column, we have minus 2 plus 4. Second row by the second column, we have 4 plus 1 plus 4, and lastly second row by the last column, we have minus 4 plus 2 2 times 1, that's plus 2 again. And lastly, last row by the first column, we have 2 minus 4 plus 2. And last row by the middle column, we have minus 4 plus 2 plus 2. Lastly, last row by the last column, we have 4 plus 4 plus 1. If we simplify this, you end up with 1 over 9 out. And then simplifying these brackets, you have 9, 0, 0, 0, 9, 0, 0, 0, 9. Close that. If you then multiply through by 1 over 9, you end up with this nice matrix 0, 1, 0, 0, 0, 1, which is again our identity matrix. Now, since therefore we want to answer the question, since A transpose was, we calculated it and we obtained it to be equal to A transpose A, which is equal to the identity matrix I rather, then we conclude A is orthogonal by the provided definition. All right, let me quickly go on to part B of the question. We were given M and we were told that M is orthogonal, right? So M being orthogonal, it has to satisfy this property that if M is orthogonal, then, so we start off from there. If M is orthogonal, then its transpose is equivalent to its inverse. All right. So we are being asked to calculate M inverse times X. Then this will be equivalent to, say, M transpose by X, because M inverse and M transpose are the same, emanating from the definition of M being, from the property of M being orthogonal. Now, so let's have M transpose. So we are given M, so rows into columns and columns into rows rather. It's one and the same thing. You convert rows into columns or columns of M into rows. So you end up with the M transpose being cos omega t minus sine omega t 0 sine omega t cos omega t 0, and lastly 0, 0, 1. Okay, so this is our M transpose, and the matrix X is given as minus omega squared 0, omega 1, 0, and minus omega. Now let's do the multiplication. So row by column, cos omega t times minus omega squared is minus omega squared cos omega t, plus omega times sine omega t to be omega sine omega t, plus 0 times 0. I don't need to write that. Plus the 0 is just, it will remain that. So this position, now we have to say the first row times the second column. So that will be cos omega t times 0, that's a 0. 1 times sine omega t, that will be sine omega t, plus 0 times minus omega. So it will be like that. And second row by the first column, we have minus omega squared, or it will be positive this time around. Minus and minus gives me a positive. So omega squared sine omega t plus omega cos omega t plus 0 times 0, which is a 0. Don't need to write anything there. And this position, I'll have to say second row times the second column. So minus sine omega t times 0, it's a 0. Cos omega t times 1, it's cos omega t. 0 times minus omega is 0. So I don't need to add anything. So, and lastly, we have to say 0 times minus omega squared is a 0, plus 0 times omega 0, 1 times 0 is 0. So in this position, we have a 0. And lastly, 0 times 0 is 0, plus 0 times 1 is 0, plus 1 times minus omega is minus omega. Okay, so this is the answer. Right, so this was the final solution if m is given to be omega to be orthogonal by definition. All right, thank you for paying attention, and I hope you find it very easy. Bye for now.